Welcome, 6th grade, back to Flip Math. This is lesson 1, and to start, I'm giving you a quick preview of something like what your notes should look like as you finish up doing your notes. Remember to put on the left side you have terms, and on the right side should be your examples. So you have this nice dividing line down the middle that lets you know exactly where both parts are. So you just have that quick reminder as you go through this, so that you are doing this correctly. All right, let's get into lesson 1. As you look at lesson 1 for this year, we're starting by looking at a number of different properties that can be found in math. Right? As you look at this problem here, you see 345 plus 67, and then you also see the number 67 plus 345. And as you're thinking about this, you're realizing that whatever way you do this problem, you're actually going to get the same answer. An answer of 412. It doesn't matter. It doesn't matter if the 67 is first or if the 67 is second. Now what we see here is we see a very unique property in math that's known as the commutative property. The commutative property of math, as it is applied to addition, says that you can add numbers in any order. I can put 345 plus 67, or I can go the other way around. And whichever way you go, you're going to get the same answer. And that's something unique about addition when it comes to math. So, remembering that commutative property. Moving on to example 2. As you look at example 2, we have a pretty similar problem, right? Addition problem, adding these monies together. And we see that the decimal point has been lined up to ensure that our place values are in the correct spots. And as you do this math and solve this problem, you realize you're going to get an answer of $18.75. And so we've added those numbers together to get 1875. Now, once again, we have another property that we can talk about when it comes to math, and that would be the identity property. Now, this identity property has a lot to do with all these zeros in this problem. We see it's a 5 plus 0 plus 0, a 2 plus a 7 plus a 0, and really, I'm sure as you look at this problem, you didn't even think about saying plus 0, plus 0. We understand that 5 plus 0 is 5. So your mind mentally is saying 5, 0, 0, put the 5 straight down, right? And you can put that 5 right there. 2 plus 5 is 7. You didn't even add a 0. And that's where the identity property comes. Identity property tells us that when we're adding with zeros, you're going to get the answer of the other number, right? So if it's 5 plus 0, you know the answer is going to be 5. And that's known as the identity property. Moving on. As we move on to example 3, we start to look at the idea of difference or subtraction. When you look at this problem, you might say, okay, 345 minus 67, 67 minus 345. And you might quickly say, well, look, that's the commutative property. However, you have to take a step back and realize that that would not be true. Even though our numbers end up being very similar, here we have a positive 278 compared to a negative 278, which are very, very different numbers. Because subtraction doesn't work the same way as addition. And so when it comes to commutative property does not apply to subtraction. When I subtract, I have to have the larger number on top and the smaller number on bottom to correctly add those together. All right. And last but not least, we get into the idea of fact families, right? If I take 11 plus 14, that's going to equal 25. And I can rearrange these, and I still get the same idea. And so as I work with that idea, I can understand that 14 plus 11 equals 25, just like 11 plus, oops, grabbed the wrong one. Still grabbed the wrong one, right? Either order, I'm still going to get an answer of 25. Just like I understand that these numbers can work together in a different way, right? I can take this plus sign, maybe I can take this plus sign out, and I can put a subtraction sign in here, right? And now, instead of my 11 being in front, it's going to be back here. If I take my larger number, right, larger number minus the smaller number is going to give me this idea, right? 25 minus 14 is going to give me 11, just like, just like that is also going to give me a correct answer. And so together, what I've really created is a fact family, right? 11 plus 14 equals 25. 14 plus 11 equals 25. And then if I go with the subtraction signs, I can go 25 minus 14 gives me 11, just like 25 minus 11. So we have that fact family with addition and subtraction. So we have that idea. All right. So commutative property, identity property. Commutative property doesn't apply to subtraction. And then, of course, we have fact families. So here's your sample problem to get you on your way as you finish up your notes. And we'll start with this one. That is lesson.